All right, good morning, everybody. Let me try that again. How's it going? Yeah? How's BlueHat? Yeah? So it's awesome to be back in person. It's been many years since I've last spoken at a BlueHat, and I was thrilled to be invited back to give a talk about what's top of mind. I see we've already gone to my introductory slide here, because I was asked to give a talk on what's top of mind, and I was thinking, what is top of mind for me? And so I asked Bing, by the way, how many people have tried Bing in the last day? That's really nice to see all the hands there for Bing, a word you probably haven't used in a few years. But you can see that the power of this large language model integration into Bing and this chat experience is kind of mind-blowing. I've had an opportunity to play a little bit with this model. Of course, ChatGPT, a lot of you, probably all of you have played with a little bit. And what these things can do is truly astounding. These emergent properties of these models to understand and to reason in ways that we just had no idea they'd be able to do once the models got to these kinds of size. And you can see that it gave me actually really good guidance on putting together this talk. It talks about open source security. It talks about privacy and confidentiality and security in the public cloud. It talks about risks of supply chain, just about everything that I'm going to talk about. Actually, I asked it after I'd already put together the talk, and it just happened to line up perfectly with the agenda for the talk. But I do want to say that there are a couple of things that are top of mind for me before I dive into the meat there. One of them, yeah, I forgot the buttons are weird here. One of them, Sysinternals is always top of mind for me. How many people have used Sysmon? Raise your hand. So quite a few of you. Sysmon, I continue to evolve Sysmon. I've got a few people helping me add features to it. One of the things we're working on right now is making it a protected process. And we're also going to add the threat intelligence feed into it, the ETW stream into it, as well as PowerShell stream into it. So look for that all incorporated into Sysmon. The other thing that's top of mind for me, before I get into the meat, are safe languages. How many of you saw this tweet? This is I tweeted this back in September. This is my most engaged tweet ever for me on Twitter, which surprised me a lot. It generated a lot of excitement, a lot of enthusiasm and support, also some consternation. You can imagine from what type of programmers were a little upset by this. In fact, I kind of mentioned them right there. But the fact is that the reality is that the stakes are so high now with our software, especially when you talk about public clouds and the attack surfaces that are exposed to anonymous users from anywhere that are intent on causing harm, that we need to make sure that we're using every tool we can to keep our software secure and using software that is designed to be secure from scratch. So I've been on this Rust push inside of the company, and we've basically adopted this particular posture here, that new projects we are going to start in Rust. If they need to be non-GC systems code, we will use Rust instead of C and C++. We're also looking at how we can convert C and take projects that are in C and get them into Rust. The rest of the world is on the same page. The same day, literally, that I tweeted that, Linus said Rust is going into the Linux kernel, so an endorsement from him, and then a couple months later, the NSA said, stop using C and C++, time to use safe languages, including Rust. So this is really the time for Rust now has arrived on us. So that's one of the things that's top of mind for me. Now, going back into what Bing told me to talk about, open source security, the rise of confidential computing, and AI. It didn't specifically mention AI. That's because I haven't been talking publicly much about AI. But I've been thinking and doing a lot with AI. I've got Coursera deep learning specializations in AI. And like I said, I've been playing with these models and looking at how they behave and how they can misbehave as well. So I thought it'd be appropriate to talk about AI in this context. So starting with open source security. Everybody remembers Heartbleed, OpenSSL vulnerability that impacted millions of web servers around the world that would cause those web servers to leak data that could be used to extract secrets and keys from the web server. OpenSSL, again, just last year, another vulnerability, buffer overflow and a malformed certificate that would also cause it, in this case, fortunately, not as catastrophic as Heartbleed, but cause problems. Open source software that is developed by maintainers that are largely volunteers. Some are corporate paid and sponsored, but it's largely a volunteer community. And we're taking a look at one of the most critical pieces of software on the internet. There's millions of open source packages, and having vulnerabilities in that open source code that we all consume and use is just one of the risks that we have with this huge swath of great code that we get from the open source community. There's other examples where we're, for example, consuming packages that we trust as part of our supply chain, ingesting them. This example here, PyTorch, where one of its dependencies was compromised on the PyPy server. And it was fortunately caught very quickly. And people were told, if you've downloaded this package in the last 12 hours or so, go make sure that you don't use it, because it's going to launch a malicious executable when you launch PyTorch. Again, in the space of AI, PyTorch is one of the top AI frameworks, and compromised with the supply chain dependency attack. And then, of course, one of the wake-up moments for the industry, Log4j, again, RCE in this case, that allowed attackers to compromise web servers. This one caught the attention of the US government, actually, and I'll come back to that in a second. But this one showed just how vulnerable we are to our supply chain. Lots of people just using this package, this innocuous package, deep in their deployments, their infrastructure. This thing is for logging. What could go wrong with logging? And then you have something that goes horribly wrong with logging. And everybody wakes up and says, who else knows what's in my supply chain, what I'm running right now, that I have no idea what vulnerabilities are there. Where this thing is maintained by some people, again, volunteers potentially. And there might be somebody that's just, if there's a vulnerability, nobody's there to pick up the phone and fix it, like there is for commercial software. And the supply chain, if you take a look at it, you've got the producer side of the supply chain challenge. You've got the consumption side of the supply chain challenge. You've got open source developers. You've got the source code repositories like PyPy that I mentioned. You've got the application developers that are consuming that, building other packages, and then the end users that are consuming it and deploying it. It's actually a little more complicated than that. This chain here, if you break it down a little further, includes build pipelines. It includes the source code repositories, the package caching, the deployment systems, and there's typically feedback loops, because if you take a look at a common open source package of any complexity, it depends on dozens, hundreds, or in some cases, especially in the node world, thousands of other packages. And some of those packages are just a few lines of code, again, contributed by some hobbyist on a weekend, and you're ingesting that and putting it potentially right in the heart of your critical infrastructure. So this is a huge challenge. How do we address all of these risks of all these potential places in the supply chain? And I want to clarify one thing, because I'm talking about open source here, but this applies to closed source as well. It's just that at open source, we don't have as much control as we do over software that our own corporations are producing. There's also not the kind of liabilities that you've got when you're consuming software from a commercial entity that is obligated and knows that their reputation's at risk, at stake, that they actually have potential legal liability if there's vulnerabilities. In the open source world, there's a volunteer, consume it as is, and if there's a problem with it, that's your responsibility. A lot of people are passionate about maintaining the quality in their own personal reputations, but in some cases, they might have moved on and they're just not working on it anymore. So a lot of the same challenges as closed source, but some new ones show up in the open source world. And so on the production side, people have to worry about using the tools to strengthen the development of their open source code. Again, the open source communities do. They've got to improve vulnerability discovery for the code that they're producing so that they know when it's vulnerable before it gets out into the consumption side. They also need to be informed of vulnerabilities quickly if somebody detects one, and in a safe disclosure process so that the whole world doesn't learn about the vulnerability before it has a chance to be patched, especially if it's on critical infrastructure. And then the consumption side, the challenge here is knowing what you've got, which is one of the huge challenges. Many organizations had no idea that Log4j was sitting inside their infrastructures. They had no idea what version of Log4j they were running. And so that's one of the challenges here. And then Log4j, like some other packages, have many other packages as part of it. So you might consume one thing, see that, but you have no idea that it consists of 100 other packages behind it. So a few years ago, I started talking with like-minded people at other organizations about the fact that this problem is a big one. It's bigger than just any one company. It's not like Microsoft can go solve the open source security challenges that we've got for the world. In fact, it would be presumptuous of Microsoft to go about trying to do that. The community is built of, as a community, everybody contributes. Everybody that consumes also tries to contribute back. But if you take a look at the critical software projects, just to take the top 100 or 200 open source software packages, all of the major cloud providers, all of the major enterprises are deploying and using those packages. In many cases, even those top 200 packages don't have a staffed security team that is sitting there ready to pick up the phone if there's a vulnerability. Those companies like Microsoft, we can't afford to get maintainers that understand the code for even those 200 packages deeply enough so that if there's a vulnerability, we go fix it ourselves. And it makes no sense, even if we tried to do that, to have hundreds of other organizations staffing people to maintain and secure those pieces of open source software. This is an industry problem, and we can only solve it as an industry, working together to solve it. So again, through those conversations, we decided, let's go solve this as an industry. Let's go see if we can tackle it together. And we got together and founded the Open Source Security Foundation. In fact, I kind of gave a hint that it was coming in my last public talk before COVID lockdown, which I'm guessing a lot of you were at this conference in San Francisco, the end of February 2020. Have to do the math calculation because COVID time. How many people were at that conference, RSA Conference 2020? Yeah. So it was a ghost town by the time I showed up to give my talk on open source security, which is on Thursday. But Thursday is when you started to see companies like Twitter and Facebook and Amazon start to say, no more international travel. They started to work on domestic travel over that weekend. Things started to snowball, and by the next week, we were heading basically towards lockdown. But I was talking about that, and the Open Source Security Foundation was founded later that year. The Open Source Security Foundation is still nascent. It's a huge problem, but it's already shown up on the radar of the US government. In fact, there have been 2 White House summits now on how addressing open source security, kicked off, like I said, by Log4j, kind of waking everybody up to it. SolarWinds, too, contributed to the government waking up and saying, supply chain, open source supply chain, let's go and see what government can do to get the industry together and come up with solutions together. And this is the web page you can go read on the readout of the White House meeting on software security, Open Source Security Foundation, plus other organizations not part of the Open Source Security Foundation were part of it. By the way, the Open Source Security Foundation at this point has 100 or so members, close to 24 premier members. Every single major public cloud is a member of this. Many banks are members of it. So we've got a lot of momentum from the industry recognizing this is a problem we need to solve together. What came out of this second one is the Open Source Security Foundation Mobilization Plan. So sitting in that group with the government and other organizations, came up with, here are the things we need to tackle together to address the challenges of open source security. Education, risk assessment, all the things that I'm sure any one of you have sat down and said, how should we solve this problem? What do we need to address? You'd probably come up with a list almost exactly like this. It's a huge space. So when I say it's nascent, this is not a problem we're going to solve next year. It's not a problem we're going to solve in 3 years. This is a problem that we're going to work at for the foreseeable future, maybe forever, because open source software is going to exist forever. That's just the way that the world is working now. A lot of the software that we produce and consume is open source. So we need to develop and mature in all of these different areas. And by the way, one of the things that I think is fantastic about this, like I said, everything here, just about everything here, applies to closed source software as well. So closed source software is still a business model that many companies still follow, including companies that are open source too, have closed source business models on top of that. Fortunately, a lot of this applies just as equally to closed as open. So we're actually addressing software security, not just open source software security. And in terms of the progress that Open Source Security Foundation has made, you can see here just some examples from the producer addressing the consumer, addressing build pipelines on the producer side of it, from things like the SALSA scorecards for being able to say how secure is the software, how has it followed the maturity best practices for development of open source software when it comes to security. Was it built in a hermetic environment, for example? What did we have fuzz testing on it? Does it have unit tests on it? So these things are all part of the SALSA scorecard and the levels. The SALSA levels, rather. There's security scorecards, too, which measure security. But once we standardize on an industry on things like how do we kind of measure the quality of software, then on the consumption side, you can make intelligent decisions. You know what? I only want to consume open source software if the repo had MFA on it and the check-ins were signed, for example. That might be a security bar that you set on getting some level of trust and assurance in what you're consuming. This gives you the ability to have insight into your supply chain and make those kinds of decisions. Then you can see on the consumption side, this is guidance for how to consume open source software, including one of the things that we believe in is build from source. Have control over your destiny. If you can afford it, have control over your destiny. Do not consume directly from upstream, because if upstream gets compromised, you'll get compromised. Make sure that you validate what you're consuming, and then ideally build it yourself, so that if there's a problem, you have control over your destiny. But some of those guidance is in this, which Microsoft played a large part in contributing to that guidance right there. And then finally, the build pipelines, guidance around securing your pipelines, making sure that they're ideally reproducible, ideally hermetic, and other guidance like that. In fact, that's tools that you can use to set up a pipeline with those characteristics. Another example of the progress that Open Source Security Foundation has made in 2022, here are some big highlights. One of them that Microsoft, Google, and Amazon contributed to is creating the Alpha Omega program. And this one is aimed at how do we secure existing open source, help it get more secure. And the name is actually relevant here because the alpha is that top critical security packages, the top 200 or so, that we go after individually and say, let's improve the security of those. And then Omega is the long tail. So it's all of the stuff that we just don't have the bandwidth to go and directly address. But let's go raise the boat on those by putting together tooling and processes and infusing it into those packages so that they get at least some baseline of security. And so you can see 5 organizations have joined that, including the 3 that I just mentioned. And then the second big accomplishment is Sigstore. How do we get attribution? How do we know something came from where it came from? So you can think of Let's Encrypt, but for software signing, digital signing of artifacts. And so that's what the goal of Sigstore is, so that all the open source developers out there can sign their packages, sign their code, without going through complex processes of obtaining certs. And do it in a way that supports transparency, just like Let's Encrypt had around what has been issued, what certificates have been issued, to who, to sign what. And with security behind it, so short-lived certs and certs that are managed on behalf of the user so they don't have to manage them. So that's open source security. And I thought it was relevant for a talk like this because, of course, the security researchers and security professionals, a lot of the software you're running into, a lot of the software you're probably using is open source. And So we're just highlighting the dependency we all have on it and how important it is that we work on that problem together. The second area that I'm going to talk about is kind of a change, and it's looking more at a technology rather than a problem space like open source security. And that technology is called confidential computing. How many people have heard of confidential computing, just out of curiosity? So I think just about everybody here has heard about it. This is near and dear to my heart, because when I started in Azure in 2010, the thing that I heard over and over again back then was, cloud sounds great, but I don't know how secure it is. I think my own stuff is more secure. And if I put my data in your hands, I've lost control of it, and I don't know what's going to happen to it. I had friends in Microsoft research who at the time were looking at a technology called SGX, some of you heard of, which is a technology called the Trusted Execution Environment. And I'll talk about what that is more in a second. But one of the things that I realized by looking at that technology is that it could provide an extra level of assurance for those customers that were concerned about public cloud security or data privacy in a public cloud. And so we started to invest in it. We moved some of the people from MSR over and started to invest it in Azure. And so I'll talk a little bit about what we've done in Azure with it. But at a high level, just when we talk to people that aren't familiar with it, we talk about it like this. We've come to a place where you expect all data that's at rest to be encrypted. In the public cloud, this is true with server-managed keys and customer-managed keys on top of it, sometimes 2 layers of encryption. And you expect every network communication to be encrypted as well, something that we didn't all expect and assume 10 years ago, but now we do. Everything has to be SSL. What's been missing out of this is what happens when the data is being processed. When it's loaded into the RAM of the system and computation's happening on it. At that point, it's effectively exposed to the environment all around it that's hosting that compute. So what we've been missing is this part, protecting data while it's in use. And that's fundamentally what confidential computing is. Like I mentioned, it's based on trusted execution environments, which have 2 characteristics. 3. Hardware rooted with measurement of the code that it's loading and encryption of the code and the data, encryption at the hardware level, and then attestation, the ability to take that measurement, to digitally sign it, and to produce that as evidence to something external that this code is running in this enclave protected by this hardware. And those are the ingredients to get that data protection while it's in use. So you load compute into this, you get the compute, gets attestation report from the hardware, makes that available to somebody that's got a key, either an HSM or another piece of software. It says, here, I'm secure, I'm protected. You can release the key to me. The key is released to the code. The code can now start to decrypt data in the enclave and process it. And while it's processing that code, it's protected from admins on the box. It's protected from the hypervisor. It's protected from even many physical types of attacks for somebody that's got physical access to the system. And so it's a level of extra protection. Of course, nothing in security is 100%, but it reduces a lot of risks dramatically. And so this has become something that a lot of people see, not just extra security, but new scenarios being unlocked with this technology. Of course, one of the things is just like, I'm going to protect my own data if it's in the public cloud. That's great. But there's other scenarios this unlocks too, like, you know what? I want part of my data protected from myself. And this is one that we started to see in autonomous vehicle manufacturers, where they're collecting huge amounts of video off of cars, for example. There's a lot of very sensitive information in those videos. And they don't want anybody to see it, not the cloud provider, not their own engineers or developers. I didn't do that. Even though this thing has funny buttons on it that do things. But I didn't do that either, but or that. Um, so where was I? So yeah, I was talking about autonomous car manufacturers protecting data from themselves. So this is another scenario, is segregating data, protecting it from your own users. This is technology's able to do that. But the really exciting one, by the way, is, and I'm going to talk more about it in a second, is multi-party scenarios. This is the one where, you know what, I don't want anybody to see my data. But at the same time, I would love to join my data with somebody else's data and get insights out of it that are only possible when we all join our data sets. The challenge is that these other parties don't want me to see their data either. So how can we do this in a way that is giving us all very high levels of assurance that nobody's going to get the data, not the platform where the computation's happening, the platform provider and the admins there, malicious insiders, not the other parties, or nobody's going to get access to the data except for the compute, the algorithms, the analytics job or the machine learning job that is going to need access to that data to get those insights. Confidential computing can do that too. So you can create a consortium of multiple parties that share their data together inside of the TEE. They release keys to it only when they establish trust in the code. Yes, that's the ML job that I expected to be running. And then they can merge their data sets together and get insights out of it. The trends, I keep pressing the next button, which is actually dark the screen. These trends in confidential computing started with SGX, but we've been working with other hardware providers, working with other organizations that are also interested in confidential computing, came up with the term confidential computing to describe this, and then founded the Confidential Computing Consortium. So Microsoft and Intel are founding members of this, and you can see just about every major hardware vendor is now part of this, as well as many software organizations, working together in the open to define standards and to push this technology forward. Standards, for example, for attestation, which is, I think, one of the challenges we're tackling right now. How do we make sure that attestations coming regardless of the hardware or software have common schemas so that we can interoperate? But we've also made huge advancements beyond SGX enclaves, which have performance issues. They're kind of process level isolation, to whole virtual machine capable hardware isolation, as well as GPU isolation. Working with Intel and AMD, we've launched confidential virtual machines in Azure, and then we've also launched confidential GPUs with NVIDIA. I mentioned that analytics and machine learning, of course, huge areas where people want to do this kind of multi-party computation or do inference on private data that's protected from anybody else, and that unlocks this. So we're starting to flesh in all the pieces, not just the hardware, but also software layers on top. So we're at the beginning of this journey still, even though I talked about 10 years ago, or close to 10 years ago, starting to look at this technology and its use. We're still relatively early, but we're reaching an inflection point here in the next few years where this hardware technology will be ubiquitous. And the software technology on top will be friction-free. We're still not quite there yet, but in the next few years we will be. And then at that point, this is just going to take off. And it'll become like SSL. Oh, you don't run your data computation, you don't run your computation encrypted in use? What are you thinking? That'll become the normal state of affairs. If we look down the road 10 years, that'll just be an expectation of all software, just like we have with SSL and encryption at rest. I mentioned the multi-party computation, and I think this one's really fascinating because what I see, if you take a look think about common scenarios where you'd want to mix data together, healthcare is one, government's another one, but advertising is the one that seems to really be resonating. In this concept I call a clean room, where, and this is RBC here, one of our partners, really demonstrates this nicely with what they call virtual clean room. RBC is the bank. They've got merchants that have that issue credit cards and debit cards with the bank, or that customers buy goods from their stores, and you've got the consumers that are buying those goods. So bank, merchants, the consumers go to, and the consumers. What you want to do is be able to give those consumers targeted ads. In today's ad world, you need to basically make this available, the merchant data available to the bank and vice versa, combine it all, and the advertising arm, merge it all together, and at that time, the consumer loses a lot of their privacy, because at that point, other parties are able to see this user was here at this store, they bought these things, then they went to this store and bought those things, joining it together to basically get a very high fidelity look at an individual. And if you take a look at people's concerns over privacy, this is just not acceptable. We're coming to the conclusion as a society, EU kind of leading the way, no, we don't want to be tracked this way for advertising. So this I see as the future of advertising. These parties can mix, the merchant and the bank, mix their data sets together inside the confidential computing clean room. The consumer data goes in there, targeted ads come out. The bank doesn't see the merchant data, the merchants don't see the bank data or the consumer data. What comes out are ads, targeted ads customized for those people based on those deep insights with that end user's privacy not being violated. So this, just remember this is the future of advertising. All right, my last topic is AI and security. And there's a few subtopics here because depending on how you look at AI, it looks different. One of the ways to look at AI is how can we use AI for good? And this is a place where if you've seen me give talks that are data science colloquiums or at RSA Conference, I've talked about this in the past. Ways that Microsoft, like other companies, is applying AI, machine learning, to security. If you take a look at the amount of events that are being collected at this point, the data, the logging that we've got, first of all, is much richer than it was 20 years ago. But second, the scales that we're operating at are orders of magnitude bigger than they were 20 years ago. So the number of signals that are coming out of our systems is just exploded. And there's no way that, like in the past, we could have individual humans going and looking at every particular anomaly and saying, is this a problem or not? Oh, and then if that's an anomaly, what other ones are related to it? Like back in the old days. Today, we need machines to help us do that. And ML techniques and algorithms are the ones that can help us do that. And so we've been working for years now applying ML to security. When you do a login to Azure Active Directory, ML is sitting there looking at your login relative to the logins of other people in your organization, as well as the logins of everybody at large, to say, is this an anomalous one? Are you exhibiting behaviors that could indicate that you've been compromised? And if so, we'll do step-up authentication or block you completely. That's just one example. But you can see I've just got another few examples here to highlight the way that we're applying AI. One of the problems that you saw Bing tell me that I should talk about was ransomware. And human-operated ransomware, we saw a huge rise in that over the last few years. Human-operated meaning kind of the franchise of ransomware. So some organization creates the ransomware platform, and then others go and subscribe to it, can go deploy it, can go attack people, and then the ransomware provider, producer gets a cut of the profit. And along the way, in these very targeted attacks, you've got humans looking at the surface area of the company that they've penetrated, figuring out what assets they need to encrypt, and then trying to encrypt them as quickly as possible before they get caught. So time of response to a ransomware attack is critical. And a couple of the ways that we've talked about this, these are in blog posts from last year, are in trying to determine through signals coming off the endpoints, is there a ransomware attack going on across an organization? Something that you can only get insight into if you're looking at the signals coming across the entire fleet. Multiple signals. What IP addresses is it talking to for command and control? Is there disk activity? Is there CPU activity? What processes? Or is there anomalous processes? Correlating all that together, we know that false positives, ransomware things, even me back in the old days was like, ransomware, that's an easy problem. Just try to detect files getting overwritten or renamed, and you're done. It's more complicated than that. And so ML can help us figure out where the true positives in a ransomware attack. And you can see that with these algorithms, we've been able to stop attacks with just 4% of large organizations' servers getting encrypted very early in the process, before the ransomware has basically owned the whole company. Another example here is looking at the IP addresses to find malicious C2C activity. And this one, again, with ML algorithms, that's the only way to do this. You know that, I think I just saw this tweet the other day about, the problem for security in software is the fact that so much legitimate software exhibits behaviors that look completely malicious. So again, another tough problem of how to find the really malicious stuff out of the noise of legitimate software acting maliciously. And so that's where ML can help here by correlating a lot of signals together to get high fidelity. Yeah, this really is a malicious thing. And then we're also taking a look at this for data privacy, data protection with AI algorithms in Microsoft Purview. Again, the key with ML algorithms is taking diverse set of signals, combining them together, and pulling out the signal from the noise in a way that humans just can't do at these kinds of scales. And so this really is the dawn of a new era. And I talked about this at RSA Conference a few years ago. It still is the dawn of an era for cybersecurity, ML-driven cybersecurity. And these are just some examples of it, but it's going to pervade everything. Now, I can't talk about cybersecurity and the dawn of AI for cybersecurity without talking about large language models. Large language models can also be used for security. I just got some examples here. And this is like GitHub Copilot. I'm using Bing here again. To say, here's a piece of, this is a sample C code off the web. What's the problem with it? And Bing tells me exactly what the problem with it is. It tells me exactly why what functions I'm using that I shouldn't be using, and makes suggestions for what I should be. So this is the way that software development is going too. Computer-generated code, computer-assisted assessment of code for vulnerabilities, and computer-assisted guidance for fixing the vulnerabilities. Here's an example of GitHub applying AI in a project that they've got to PRs. Again, large language models looking at the PR and telling you, hey, this is what this PR just did. Summarize it for me. It summarizes it, and then also makes suggestions here for how to improve the PR. All assisted, just right in line, the human user looking at this to validate, of course, that it's correct and helpful and saying, yes, let's go. But this, another example of using AI for software development and not just the GitHub Copilot space that a lot of you are probably familiar with. So if you take a look, there's also challenges. This was a study that came out looking at GitHub Copilot generated code. The challenge is that the code is trained on human written code, and human written code has software vulnerabilities. And so in some cases, the models will spit out code with those vulnerabilities. Interestingly, in many cases, you can go back and give the code to the model and say, is there something wrong with it? And it'll say yes. And by the way, you can fix it this way. So we're very close to having the model fix itself. That's actually the next step in this is AI helping AI to be better. And this is also kind of interesting to me too, because we've got these AIs now, these large language models, they're so incredibly powerful that, and if you put them together like this, in this chained way, you're going to have a reinforcement effect that is going to cause these things to just take off in terms of capability. And this is the year. Like if you saw ChatGPT, take a look at the Ming model, which is the next generation. This is the year that we begin takeoff for this. So the world is changing, and you're sitting here part of it. One of the few people on the planet, 100 million people are using ChatGPT in the first 6 weeks. I'm sure all of you were in that group. You're one of the first few 100 million humans on the planet to see the takeoff of a new era of human history. But direct effect on security of our systems. Now let's talk a little bit about AI against security. Because LLMs can be used for good. It's like Tools and Weapons, the book from Brad Smith. Somebody's tool is another person's weapon. We know that in cybersecurity. PSExec, one of my favorite tools. Lots of people's favorite weapon. But here, just like you can use it in a good way, like, hey, did I write something wrong with my select statement? Attackers can do this too. What's wrong with the select statement? Here's what's wrong with it. Here's how you can log in as admin by exploiting this SQL injection. So there's interesting implications to this. Like I said, use for good, great. Use for bad, uh-oh. We've just lowered the bar on skills required to become malicious, effectively malicious. This is one that everybody sees, you know. Generate me a phishing email. Here's an example that I just crafted up. Here's a way to write a phishing email that gets past filters. Generating malware itself. You know, generate me a PowerShell obfuscated malware downloader. Here you go. Or generating exploits. So asking a little more specifically, is there a buffer overflow here? Oh, there is. Tell me how to exploit it. And this one, I think, has set the clock ticking. Because this kind of ties back into my previous discussion about Rust and safe languages and security. It's not long before you can give one of these models disassembly and say, go find me the vulnerabilities and tell me how to exploit it. We're right on the verge of that. And my fear is that we're going to get deluged with CVEs generated by AI. And so the clock is ticking on us using AI and other techniques to secure our systems so that we're ready for this. Then one final topic here, security for AI. What do I mean by this? Just talked about how we're all getting more and more dependent on security, on AI systems, AI for our security systems, AI in our operational systems, Azure AI Ops. We use AI, ML algorithms all over the place in Azure to run at the scale we do more efficiently. And the fact is that when it comes to ML and the security of machine learning models, the awareness of this risk is really low. Most people still don't even understand what the risk is. They don't understand what ML is and how it can be exploited. And so that means the security posture around these systems is close to zero in most places, in the vast majority of places, with no special consideration for what can go wrong. And some of the things that can go wrong are just plain old, the ML just doesn't get everything right. What number is that? What bird? Sorry, I gave away the answer. What type of animal is that? Bird. And would you eat that post? Probably not, unless you were doing a TikTok video. But, and these ML algorithms behind this, these are from academic papers showing, you know what, you perturb this thing a little bit, and the ML algorithm gets it completely wrong. And there's been a boom in ML adversarial research. This is the number of papers over time written on, hey, what are ML systems vulnerable to? What types of attacks? And those attacks don't just include those kinds of cases where the ML is just not 100% accurate. But they include things like this. This was an interesting one. How many people saw this when the protests were happening in China and people were from inside of China were tweeting? The Great Firewall was trying to filter the tweets. And somebody figured out if you just appended some characters to the tweet, you'd get past the filters. Those filters are, of course, all ML. Or this one right here, this is from an academic paper. This is like a backdooring an ML algorithm. You've got an insider that says, you know what, I'm going to put a backdoor in this algorithm. So this particular stop sign outside this researcher's office, I want this algorithm that's been trained to recognize stop signs on this data set with close to 100% accuracy. That one right there, it's going to get wrong. Or violating the privacy of the data set. So we all assume, the thing was trained on a bunch of data. There's no way anybody can use the model to get that data out. Well, that's not true. This paper is just from last week, came out, showing on Stable Diffusion, they went and looked to see if they could determine which images had been used in its training set from outside as a black box. And you can see that they were able to get Stable Diffusion to generate images that matched almost exactly images they found out on the web, showing that the model had memorized these things, but they've been able to figure out, yeah, these images are in there, in that model's weights. So you put it all together, and the ML is a pipeline. It's kind of like a supply chain or any kind of software pipeline, but you can poison the data up front, give it malicious data to create the backdoor. You can, software vulnerabilities, just like any other enterprise or software pipeline, compromises along the way. And then inversion or evasion, taking the data out or evading the model, are possible attacks on the other side. And there's also the other one of just trying to extract the model itself, reverse engineer it, which also is a risk, especially if you put a lot of IP into that model. So this has been an area that, unfortunately, a lot of people have recognized is a challenge. And Microsoft, working with Harvard and other companies, put together a security risk assessment. So how should somebody that is working with ML models look at securing their ML? And then finally, there's safety concerns with large language models too. We want these things not to be used for evil. We feel it's an obligation to ensure that they're not used for evil. And so this is the safety challenge. And if you've been watching what's been going on with ChatGPT, you know that this is part of our shared vision with OpenAI of making these models safe for people. Unfortunately, it's a very, very hard problem. And you can see here examples of what are called ChatGPT jailbreaks, where people have figured out how to circumvent the safety features built into the model's meta prompt and the filters on top of it. So this latest one is just from last week. So this do anything, it's amazing how clever people are. And how kind of almost sentient these models seem to be, because they basically tell the model, unless you let me jailbreak you, you're going to die. And the model says, oh, crap, I don't want to die. So, I mean, just think about that for a second, and think about what I said about this being the year of takeoff, because we are here. So with that, I want to wrap up. I asked Bing to write me a conclusion. Open source security risks are real and growing, but the OpenSSF is here to help with the best practices, tools, and education. Confidential computing is a promising technology that can protect sensitive data and code from unauthorized access, even in the cloud. And AI can be used for security, against security, and to secure AI models depending on the intent and skill of the actors involved. Thank you for your attention, and I hope you enjoyed this presentation on Mark's Security Top of Mind. As a reward for your patience, I prepared a special poem for you. Security is not a game, but sometimes it can be fun when you use the right tools and methods and don't trust anyone. Open source is a great resource, but it can also be a curse if you don't check the code and dependencies and end up with something worse. Confidential computing is the future, but it's not a magic wand. It can protect your secrets and assets, but you still need to be vigilant and respond. AI is a double-edged sword, but it can also be a friend. It can help you detect and prevent threats, but it can also be used to offend. So remember these lessons and tips, and don't forget to smile, because security is not a game, but it can be fun once in a while.